Good morning, my dear esteemed participants. Today's lecture is going to be on carbohydrates. What are carbohydrates? Carbohydrates are polyhydrosyl aldehydes, polyhydrosyl ketones, or compounds that can be hydrolyzed to them. I say carbohydrates are polyhydroxyl aldehydes, polyhydroxyl ketones, or compounds that can be hydrolyzed to them. They are naturally occurring organic compounds containing carbon, hydrogen, and oxygen in the ratio of 2:1. The general formula of carbohydrates is CX H2Y O Y. Take it again. I said carbohydrates are naturally occurring organic compounds containing carbon, hydrogen, and oxygen. The ratio of hydrogen to oxygen is 2:1. That means for every 2 hydrogens, you have 1 oxygen. And I said carbohydrates have general formula of CF H2Y O Y. Carbohydrates are the ultimate sources of most of our food we eat. We eat starch containing grains. We feed it to animals. It is converted into meat and fat, which we then eat. We clothe ourselves with cellulose in form of cotton and linen and cellulose acetate. We build houses and furniture from cellulose in form of wood. Those carbohydrates provide the necessity for life. In other words, food, clothing, and shelter. Together with the paper we are writing just now on it. These are some of the importance of functions of carbohydrates. Very interesting. How do we classify carbohydrates? Carbohydrates can be classified into 2 broad groups. 1, simple sugar. 2, complex sugar or polysaccharides. So we can classify carbohydrates into 2 broad groups. 1, simple sugars. 2, complex sugars or polysaccharides, if you like. What are simple sugars? Simple sugars are sweet crystalline that are soluble in water. Examples include glucose, fructose, and sucrose. Glucose, fructose, and sucrose. They are sweet, crystalline, and soluble in water. Simple sugar can be further divided into 3. We have the monosaccharides, the disaccharides, and the trisaccharides. Monosaccharides. This type of carbohydrate cannot be hydrolyzed to simple sugar. The simpler compound, sorry. Example is glucose. That is the end product of carbohydrate. So that monosaccharide, you cannot get another simpler compound than that. Now, disaccharides. These are carbohydrates that can be hydrolyzed into two monosaccharide molecules. Example, sucrose. Trisaccharides refer to sugars that are used from units of monosaccharides and oligosaccharides. Let's look at complex sugars or polysaccharides. They are tasteless, non-crystalline, and insoluble. In other words, they are opposite to simple sugars. They have higher molecular weight as they are referred as polymers, derived from monosaccharides. Examples of the complex sugars include starch, cellulose. Now, they are sometimes called glycans. They consist of hundreds to 3,000 of units. How do we name sugars? Monosaccharides that contain an aldehyde group is known as aldose. If it contains keto group, it is known as ketose. Depending on the number of carbon atoms it contains, we can have triose, tetrose, pentose, hexose, and so on. And aldohexose, for example, is a 6-carbon monosaccharide containing aldehyde group. A ketopentose is 5-carbon monosaccharide containing a keto group. Most natural occurring monosaccharides are pentose or hexoses. Now, let's take glucose and look at it. Glucose is also known as crepe sugar or dextrose. It is obtained in food, in honey, or in the sap of plants. Glucose can be synthesized naturally by plants during photosynthesis. They can be prepared in a laboratory by hydrolyzing starch with dilute mineral acid. Glucose is used as a source of energy and in the manufacture of sweet food. Sucrose. The sugar found in sucrose is sugarcane, meaning sugarcane contains sucrose. It is also found in carrots, sorghum, and sap of trees. Sucrose is prepared by crushing cane or beets and the juice extracted with water, then purified by treatment with black lime and carbon dioxide, and then distilled and allowed to concentrate slowly by flowing across. Sucrose is not a reducing agent due to the absence of carbonyl group. Therefore, they have no any effect on saline solution. Sucrose is used in food making, sweet and for preservation. It is used industrially in the production of ethanol. Now let's look at starch. Starch is called a glycan. It is a polysaccharide with molecular mass of 10,000 to 350,000. It consists of about 100 to 300 repeating glucose units, forming branch molecules. Starch is found in cassava, yam, wheat, rice, etc. How can we prepare starch? Starch is prepared by pushing the starch material or the starch and the starch is extracted with water, and the resulting suspension is removed by evaporation. Starch is a white powder with no taste at all or smell, and it is insoluble in water. Starch can be set to jet when the aqueous suspension of the starch is warm. We can hydrolyze starch using dilute acid to smaller units like this. Note that starch does not reduce saline solution due to the absence of free carbonyl group. Where can we apply or use starch? Starch is used as a food in the production of ethanol. It also serves as a stiffening agent in textile industry or laundry, popularly known as starch that we apply on our clothes. Cellulose. Cellulose is a glycan also with molecular formula 10,000 to 100,000. Cellulose are not brands, but starch are brands. Don't forget, cellulose are not brands, but starch are brands. And the molecular mass of starch I will say is from 10,000 to 250,000. But for cellulose, from 10,000 to 100,000. Cellulose is a main component of plant cell wall. It is found in key cells of the wood substructure. It is not easily hydrolyzed by dilute acid, so it is usually carried out by enzymes. So cellulose found in digestive system of bacterial plants and mammals. Cellulose is used in manufacturing of paper. Let's look at the distribution of carbohydrates before we run. Carbohydrates serve as source of energy and source of energy as glycogen. They form major portion of the supporting tissue of plants and some animals. They play large role as part of nucleic acid DNA and RNA. Others are found as components of variety of natural products, such as bacterial cell walls, blood groups, substance, and cartilage. In recent years, a new growth point has developed in that there are many carbohydrate substances, most of which contain amino acids. Thank you very much. In our next lectures, we are going to have another new topic. Thank you.